Welcome to this lesson on vector addition. Today, we'll explore how to combine forces and velocities using both graphical and mathematical methods. Understanding vector addition is essential for solving real-world physics problems involving motion and forces. Vectors are quantities that have both magnitude and direction. In physics, we often need to combine multiple vectors to find their net effect. For example, when multiple forces act on an object, they combine to produce a net force that determines the object's motion. Similarly, when dealing with velocities, such as a boat moving in a river with a current, we need to add the velocity vectors to find the resultant movement. Vector addition helps us understand how these quantities work together. There are two main approaches to adding vectors. The first is the graphical method, which involves drawing vectors to scale and using geometric construction to find the resultant. This method is visual and intuitive, making it easy to understand conceptually. The second is the mathematical method, which uses component analysis and algebraic calculations. This approach is more precise and efficient for numerical problems. Both methods will give you the same answer, so you can choose the one that works best for your situation. The triangle method, also called the head-to-tail method, is one of the most common graphical approaches. Here's how it works. First, draw the first vector to scale with its proper direction. Next, place the tail of the second vector at the head of the first vector. If you have more vectors, continue placing each new vector's tail at the previous vector's head. Finally, draw the resultant vector from the tail of the first vector to the head of the last vector. This resultant represents the sum of all the vectors. The parallelogram method offers an alternative graphical approach for adding two vectors. Begin by drawing both vectors from a common origin point so their tails meet. Then, complete the parallelogram by drawing lines parallel to each vector. The diagonal of the parallelogram, drawn from the common origin, represents the resultant vector. This method is particularly useful when you want to visualize how two vectors combine from the same starting point. While graphical methods are helpful for visualization, the mathematical method provides greater precision. This approach is based on component analysis. The key idea is to break each vector into perpendicular components, typically along the x and y directions. Then, you add the corresponding components separately. Finally, you combine these component sums to find the magnitude and direction of the resultant vector. This method is more accurate than graphical methods and works well for complex calculations. To use the mathematical method, you first need to resolve each vector into its components. Any vector can be broken down into an x component and a y component using trigonometry. The x component equals the magnitude of the vector times the cosine of the angle theta, where theta is measured from the positive x-axis. The y component equals the magnitude times the sine of the same angle. These formulas allow you to express any vector in terms of its horizontal and vertical parts. Once you've resolved all vectors into their components, adding them becomes straightforward. To find the x component of the resultant, simply add all the x components together. Similarly, to find the y component of the resultant, add all the y components together. This process works because components in perpendicular directions are independent of each other. By adding components separately, you maintain the correct relationship between the vectors while using simple arithmetic. After finding the x and y components of the resultant, you need to convert back to magnitude and direction form. To find the magnitude, use the Pythagorean theorem. The magnitude of the resultant equals the square root of the sum of the x component squared plus the y component squared. To find the direction, use the inverse tangent function. The angle theta equals the inverse tangent of the y component divided by the x component. These two values completely describe the resultant vector. Let's review the key concepts. Graphical methods like the triangle and parallelogram approaches are visual and intuitive, but they're less precise for detailed calculations. Mathematical methods using component analysis are accurate and efficient, making them ideal for problem solving. An important property of vector addition is that it's commutative, meaning the order in which you add vectors doesn't matter. A plus b equals b plus a. These techniques are essential for analyzing forces and motion in physics, from simple problems to complex real-world applications.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.